Long story short, once per week before COVID, we had an allowance at one of our offices for things like sweets, chocolates, and other types of food. And as the week progressed, the stocks diminished. Where at the last days of the week, we were all out. So I decided to make this gag candy machine just as a joke where people would have to earn their candy. The idea is that, as you saw in the introduction, you use your phone and via NFC or QR code connect to the app, which is basically a web app served on a Raspberry Pi, which is inside this candy machine. Then you would be asked some questions, and if you answer correctly, you earn your candy. The dispenser will dispense some candies for you. If not, well then, better luck next time. If you want to see how I made this project, I'll go over the ups and downs in this video, and for the sake of keeping it short and simple, I'll provide you guys with the source code for whoever is interested in exploring the code. And now, let's dive straight into the project. The first idea that I had was having a bucket system and a couple of buttons with a speaker where an AI will read the questions for you and you will have 4 options and 4 buttons to respond. But after tinkering with it, I decided to scratch that idea, because if you have a bucket, you cannot limit people from taking more than one candy. So I went on Amazon and searched for some candy dispensers. And I found this one. When the dispenser arrived, I set it up, I put 3 AAA batteries and I tried it out. There's a button underneath and when you touch it, you get some candy. Next, it was time to take this thing apart and see how it works. And I started out by taking the bottom section first, and that revealed some wires and a switch for turning it on and off. Then I took the top part off, and that revealed the brains of this machine, which is basically a DC motor and a small board. And with the help of the motor, this squiggly wiggly thing rotates, and that's how you get your candy. Now I knew I wanted to trigger this motor from the Raspberry Pi on demand, but before that I did rip all the electronic parts out of the machine except for the motor. So to trigger the motor on demand, I decided to add an NPN transistor for that. In short, a transistor is an electronic with 3 pieces of semiconductor material, and they help us control the flow of the current. The NPN transistor has 3 connections, that is the collector, the emitter, and the base. With the NPN transistors, the flow of the current is from the collector to the emitter, and we use the base to switch it on and off by sending a signal to it. Before I decided to add a diode and a resistor to this circuit, I thought to wire the motor directly to the Pi, but I was a bit hesitant about the back EMF, which is short for back electromotive force. Even though the motor is small, after we cut the power to it, it might still be generating some voltage, and to prevent that, I've added a diode. You can see the whole circuit diagram here, and I'll also leave a link down in the description. And if you're wondering about the Raspberry Pi pins, I always use this image online, and here you can see what pins are responsible for what action. For me, I use the GPIO4, the ground, and the 3.3 volts, which I've later switched to 5 volts. And this is the final circuit that I built. Next, I needed to test this out, so I installed Raspberry Pi OS Lite on a Pi Zero, and I've installed Node version 10. Now, unfortunately, we can't use the latest versions of Node because after version 10, they don't support the ARM v6 except the experimental versions. So if you want to see all the available options, head over to this URL and you can see a list of all the distributions, but for me, I went with Node version 10.24. To install this version, you first need to download it and then unzip it and then add it globally, so you can copy it to your user local folder, and then we can do node -- version to check if it was properly installed, but you might need to do a reboot first before you do that. After I was done with installing Node, I went over and downloaded the on-off library from npm, and this is the library I used to send the signal to the motor. So I ran this script where on every 6 seconds I would send the signal for about 3 seconds, and I tested it out, and as you can see here, the motor is spinning. Next objective was to figure out a way to put the Pi and the breadboard inside this candy machine. As you can see, they do fit in the bottom compartment, but there's a problem. The battery compartment was in the way, so I decided to chop it off. I ended up drilling some holes around the compartment using a hand Dremel tool, and using some wire cutters, I ended up cutting in between the holes, and the last step was to sand everything down so that it looks a bit nicer. But there was another problem. The connectors of the pins of the Raspberry Pi were too high, therefore I could not close the battery compartment. So back to the drawing board, and first I tried to cut off the plastic a little bit, but then I decided just to solder the wires directly to the pins. And that did the trick. I could then close the compartment with a screw. Lastly, to hold everything in place, I used a bit of electrical tape and a hot glue gun. So I decided to test it again. And of course I wired the motor the wrong way around, and now the candies won't dispense. So I went back and resorted the wires so that it spins the correct way now, and there we go, we can now enjoy our candies. Next objective was to set up a WebSocket on the server so that we can communicate with our web application. For that, I used a WebSocket library called WS, which is a lot lighter than using something like socket.io. Next, I wrote some code that only one person can be connected at a time, and I gave everyone 30 seconds to provide an answer for the questions. Speaking about questions, I got all of my questions from OpenTriviaDB, which is free to use. It's a user-contributed trivia question database. There are some options here to specify the type of questions we want, like for example the category and how many questions we want to get, but for my project I went with only one question and all the categories. So for the time you have to answer these questions, I have a timer set on the backend, and after 30 seconds the connection will close and it will send a times up to the client. Now I've also added a timer on the front end, and we can see it in action here with this progress line. Next, I wanted to check if the connection was alive, meaning if the client lost connection, then I wanted to close the WebSocket. So for that, I've used this handy little ping pong procedure, which helped me close the connection if no responses were coming back from the client's browser. So basically, after I implemented everything, I made sure that only one person can use the application at a time. We handle errors if connections are being lost, both on the server side and on the front end side. And lastly, we have notifications for winning and losing the game. So for the last steps, I built the Angular app and I used Express to serve it from the Pi. So I had to transfer all the files to the Pi. For that, I used Windows PowerShell and then I SSH'd into the Pi, and I used SCP to copy everything from my server folder to the Pi, and then I removed the node modules and I ran npm install again. Next, I ran the server and it was time to set up the NFC. For the NFC, I got these NFC tags that you can program with an app, and as you can see here, I've added the URL, and when I approached the NFC, it did write that data to the NFC. And finally, after I ported everything to the Pi, I was done. All in all, this was a fun little project to tackle, and I can't wait to see it in action. Thanks everybody for watching, hope you enjoyed, and before I sign off, I just want to say that I have a couple of more videos like this in the works, so make sure you're subscribed if you want to see more content like this. Thank you again, and I'll see you in the next one.